Alrighty. Let's see what we have today. Longest harmonious streak. Easy, easy. We define a harmonious array as an array where the difference between the minimum and the maximum between its maximum value and its minimum value is exactly 1. Right, difference between min and max. Okay, given an integer array nums, return the length of the longest harmonious subsequence among all its possible subsequence. Subsequence being, yeah, it's just removing elements. Okay. Length of the longest harmonious subsequence. All right, so maybe here 3 and 2s, 3, 2, 2, 2, 3. Okay, and then the difference is 1 between those elements. 1, 2, 3, 4. So 1, 2, or 2, 3, or 3, 4. So those all have the possibility of being 1 apart. Here, oh, it has to be exactly 1. It can't be 0. So nothing here. Okay, so I don't think it doesn't matter the order. It looks like it could have been 3, 2, 2, 3, 2, or the 3s came before the 2s, 3, 3, 2, 2, 2. It strictly matters the count of elements that are 1 apart. Like there's 2 3s and 3 2s, and they add up to 5. So I think I can just do a counter and see what the maximum I can get between 2 frequencies that for the values that are 1 apart. Okay, so let's say counts is equal to counter of the array nums. Let's say n is the length of nums. Actually, I don't even know that I need n. Let's say the answer is initially 0, and I do need to sort if I were to go through the counts. How to best do that? I can do like for every value in counts. This might be a little. I'm going to try to skip the sort. I'll just go for every value in counts. If the value plus 1 is in counts, then the answer equals the maximum of the answer and the counts of this value plus the counts of the value plus 1. So it'll look like, for instance, 1 is a value in the counts, and then it'll say, is 2 in this array? And then if so, then whatever my previous answer is, I compare it with the number times the 1 appears plus the number times 2 appears. Similarly, if when the value is 3, it compares it 3 to 4, but 4 is not in counts, so it doesn't do anything. So that's fine. So this is not sorting, because the other way of doing sorting is you sort the values of, you look at the values that are actually there, and you just go over those. Interesting. It's above the average solution, but it's not particularly fast. How can I make this faster? How can I make this faster? I could do a default dictionary, in which case I can always have 0 and I don't have to do the if statement. Okay, let me try alternate to counts here. So let's say my counts is actually a default dictionary of integers, and I manually make the counts themselves. So every value in nums counts of that value plus equals 1. So this is pretty much the same. This could be a dictionary of the frequency, the value frequency pairings. But I don't need the if statement in this case, because I know that value plus 1 isn't counts, and it'd be just 0 if it's not in the previous version. So answer equal, oh shit. Pitch value and counts. I think that still works actually. Does it? Actually, I don't think it works. I think the reason why it doesn't work is this. I'm going to be referencing new stuff, and then it creates new keys in this dictionary. But I'm just going to just double check here. Pretty sure this is an error. I'll say like size of dictionaries changing. Yeah. Almost exactly dictionary size. So the issue here is, so in theory, let's say I do my initial for loop that goes through the default dictionary, and it's creating a dictionary where the keys are 1, 3, 2, 5, 7, like all the different values. But here, when it does a value that hasn't been found for, like let's say it's doing value 3, so it checks for value 4. When it does the value 4, it changes the size of the dictionary and actually creates a new entry where the thing is the key of 4 matches to 0 because it's default to 0. At that point, the size of counts is now like 1 more, and then this iterates through the kind of initial set of values, but then yeah, counts still has 4, so therefore it's giving an error. I can separately make a keys of counts for every unique value. Unique values is the set of counts. So for every value that's in, I guess I could have done this on the other one now. Let's see. Every value in the unique values. And this doesn't feel faster, it feels slower if I need to create a set. Wow, it doesn't even do it right. Oh boy. This should be a set of nums. I'm not sure what set of values is. Oh boy. It doesn't even work there. Yeah, so this can be 4 because it's doing 1 plus 2, or the frequency of 1 plus the frequency of 2, or the frequency of 2 is 0. No, but yeah, this doesn't work. Okay, so that temp was not great. Okay, so let me double check if this is working. Value 1 is in counts. How to make this faster? Creating a counter is pretty darn fast. Like, if value of 1 is in counts, so you're looking for the bigger one. Oh, really? There's a faster way than this. What other hacks can I do? Answer, maximum of the answer. Like I can iterate over a sorted version of the nums, maybe, of the values, sort over the values. And how is that any better? Like, even if I go over the sorted version of values, I still do the same comparisons, and I still do, yeah, sorting it doesn't seem to make like it. Sorting is just like an extra extra cost, but you're still iterating over all the possible adjacent value pairings. Sort over the frequencies themselves, but then you still need to have if statements checked to see if the values of the frequencies are correct. I guess if you sort over the frequencies and you do the pair, if you check on the values themselves, then the very first frequency that you see that works, you can break the loop for. So like for instance, if the frequency was 10, no, that's not even true. Like you're going to add the sum of the frequencies. And just because you have a bigger first frequency, the pairing frequency might be small, such that a later one is better. So you still have to go over all the possible pairings of frequencies. Does this give me any clue? Not really. All right, I'm going to try to run it one more time to see if it was random variation as to the speed of this. It was random variation. Okay. Excellent. Spend half the time on the project on the problem trying to optimize nothing. Okay. So summary, this is going to be the key point is to recognize that the particular subsequence, the particular longest subsequence doesn't the order of values in the longest subsequence doesn't matter, just the frequencies of the two values, value and value plus 1. So for example, if it's like 3, 2, 2, 7, something like this, versus something like the 3's are in front and the 2's are behind. 2, 3, yeah, will have the same turn or same length of longest subsequence as there's two threes and 3 2's. So therefore, just need to only create or determine the frequencies of each value and see what the highest sum of two adjacent values, consecutive values, two consecutive values. Where about consecutive values means value and value plus one. That'll be the longest. That sum is longest is same as size of longest or length of longest subsequence. So given that one, you need to, or ideally you create frequency mapping. Basically use counter on nums to iterate over possible value slash value plus one pairings and keep track of maximum sum of counts or sum of frequencies of those pairs, and then obviously return the maximum count, and then since counts has that frequency pairing, I just go over treat the value as the possible the lower of the two pairings, and then obviously sometimes value plus one is not there, like for instance if it's all same value, there's no two, then you need a statement to check that it's inside the actual mapping. Alright, time complexity, this can be O of n in order to create your mapping, create the mapping using counter, and to iterate over values, to get some. Like technically it'd be over v, where v is the number of unique values in the n size array, but then v can be at most n as well. Space complexity is going to be O of v, where v is the unique values in the nums array. Well, you can argue this O of which is maybe which is at worst O of n. If n, if v is, if the number of values is could be at most all unique values in n values. Anyways,